So in this section, you really are asked to find the point within an interval, right, within a specified domain that has the largest y value. Okay, so now let's take a look at this relatively simplistic function, a cubic function, x cubed minus x squared minus 4 in this particular interval. If you had the graph, it's easier, right? But if you didn't have the graph, you're going to have to use some reasoning. So first, you have to try to see if you can use the closed interval method, right? Can you use the closed interval method for this? Two criteria, right? To use the closed interval method, the function has to be continuous within the domain, right? The specified domain. Is it continuous? Polynomial function is continuous everywhere, so it must be continuous. The other criterion is the interval closed at both ends. Includes -1 on the left, includes 1 on the right, right? So it is closed. So we can use the closed interval method, but you have to specify your reasoning. Since f of x is continuous within, okay, I'm using the interval notation, -1 and 1, non-inclusive, right? We're talking about the interval, right? Between this and this. And the other criteria is the interval is closed at both ends, right? We can use the closed interval method. Okay, step 1 of the closed interval method. Find the derivative, right? You always need the derivative. Since f of x is x cubed minus x squared minus 4, f prime of x is 3x squared minus 2x. In factor form, it's x times 3x minus 2. So with that, we then determine the critical number, or numbers in this case. So what is the distinction between critical numbers and critical point? Critical number only, yep, just the x value, right? Critical point, you have to give both coordinates, right? X and y coordinates. So to determine the critical number, so set f prime of x to 0. In particular, x times 3x minus 2 is 0. Solving gives us an x value of 0 and 2/3. So we have two critical numbers, or two critical points. Then we can determine the corresponding y value, right? So f of 0 is, well, it's just 4 and -4. F of 2/3 equals 1 to 7 2/3 for x. 2/3 cubed minus 2/3 squared minus 4 is -4 and 4/27. Step 2 in a closed interval method. Determine the y values at the endpoint. So what are the endpoints? -1 and 1. So f of -1 is -1 cubed minus -1 squared minus 4. So that's -6. And f of 1 is 1 cubed minus 1 squared minus 4. So it's -4. And step number 3, what's left to be done is just comparing, right? Comparing the y values at the critical points as well as at the end point. But you have to specify that you are making these comparisons by using the phrase by comparison, the absolute max so we have this is one point, this is another point, and this is another one, and this is another one. So we have 1, 2, 1, 2, 3, and 4. So the largest y value, what's the largest y value? -4, -4, and 4 for 27, -6, or -4. What's the largest y value? Huh? The largest y value. -4, right? -4. So does it matter it happens twice? It doesn't matter, right? It's still the largest y value. So the absolute max happens at, well, now we have 2 points that have this y value. 0, -4, and 1, -4. Okay. And the absolute minimum, so now, what's the absolute minimum? This is the smallest, right? -6 is the smallest of them all. So is at point -1, -6 as required. Okay. So quite straightforward, right? If the interval is continuous and closed, continuous within that domain, right? Throughout, no gaps, no point discontinuity, no vertical asymptote. And if the endpoints, the intervals is closed, right? Both ends, use the CIM, right? Closed interval method, what I call CIM. You can use this abbreviation moving forward. Now, as a extension to this question, find the absolute max and min of the same function in this interval. Now, this is an open interval, right? -1 not inclusive, 1 not inclusive. So can you make a case for it? Try to determine what if the maximum absolute max and absolute min exist, and if they exist, what are the values? What are the y values? So first of all, can you use CIM? Can you use the CIM? Can you use the CIM? Anybody? No, right? Why not? Because it doesn't fulfill the both criteria, right? So in order to use the CIM, both conditions have to be met, right? It is continuous. That a function is continuous within the interval, but the interval is not closed. So you cannot use the closed interval method. So you can say, since the interval is not closed, even if it's closed at one end and open at the other, right? You cannot use the CIM. Okay? You can only use CIM if the function is continuous and the interval is closed at both ends. So the closed interval method cannot be used. So what do we have to do? So if the interval is not closed, meaning if you cannot use closed interval method, you can go to this flowchart and choose the correct method. So first ask yourself, is the interval closed? If the interval is not closed, the next step, find the critical numbers within the domain, right? The specified domain. So if there's only one critical number within the specified domain, you can use the first derivative test to check whether that point, the critical point, is an absolute max or an absolute min. Okay. If there are more than one critical numbers within the specified domain, you have to find the y values at every single critical number, as well as what? The limits at discontinuous points, right? Meaning limits at the boundaries, if the boundary is open. And also if you have discontinuity within the domain, you need to check the limit at each boundary, at each end of the boundary. So let's go back to our example. So same idea. You still need to find the critical numbers by finding the first derivative. So the first derivative is 3x squared minus 2x. In factor form, it is x times 3x minus 2. Next, we determine the critical number. Set f prime of x to 0. So that means x times 3x minus 2 equals 0. That means x either equals to 0 or 2/3. And then you can find the corresponding y value. The corresponding y values are f of 0 is -4, and f of 2/3. We calculated that, right? So that's -4 and 4/27. Next, you want to determine the y value or the limits at the endpoints. Determine the y value the limit at the endpoints. So now both endpoints are open, right? So both endpoints are open. So you need to use limit for those. The left-sided limit at the left-sided endpoint is the limit of f of x as x approaches -1 from the left or from the right. If you're approaching a left endpoint, you're approaching it from the right, right? So it's positive from the right. Okay. So that is just how do you determine the limit of a polynomial function? Yep. Direct substitution. So -1, right? Cubed minus -1 squared minus 4. So that is -6. The right endpoint, or right-sided endpoint, I think you just say left or right, right? No sided. Left endpoint or right endpoint. The right endpoint is the limit of f of x as x approaches 1 from the left or from the right. For a right endpoint, the limit is from the left. Okay. So again, polynomial function, you just use direct substitution. Now it's 1, not -1, right? 1 cubed minus 1 squared minus 4. So that is -4. So once you have found all these y values and the limits, what do? It's the same procedure as closed interval method. It's just that we don't call it closed interval method because the interval is not closed. You still have to specify what you are doing, explain, right? By comparison, important phrase. So now you are comparing these y values, right? Is this. I like to use solid line circle to represent solid points. And I like to use dashed line circles or oval to remind me that they are not solid points. So is there an absolute max? Meaning, is there a largest y value that is a solid point? So which one is the largest value? Well, -4, right? Two of them. So does that mean the absolute max happens at these 2 points? No, right? So where does it happen? Is it 0, -4, or 0.1, -4? 0, -4, right? Only at the solid point is 0.0, -4, right? This one is not an absolute max, 1, -4, right? And the absolute min, okay, so now compare the points, the y values again. What is the smallest y value? What's the smallest y value? -6, right? But is that a solid point? It's not a solid point. So what does that mean? Does the absolute min exist? Does not exist. The absolute min does not exist, right? As required. So this is as much as you need to do to explain your steps. And your final answer. Okay? You can graph it. Of course, not doing a test. You can graph this to graphically to visually show you the scenario. Okay.
Sure.
Yep.
Just like solid gas circles on the test, is that good enough or that?
No, explain the steps, right? I need you to explain it like that. Yep. It's not a whole, this one's not a whole, right? But it's not included, yeah. No, but we want the absolute, right? The key point is the absolute. Is that the absolute lowest? Yeah. So yeah, it cannot get to -6, right? The y value cannot be -6. But what is the number closest to -6? What is -5.999 or -5.99999 or -5.9999999? So it doesn't end, right? So you cannot get close enough to -6. Okay? That's the definition of limit. Yep.